Recording started.
This is problem number 2 in section 10.4. So it says plot the point in polar coordinates and find the corresponding rectangular coordinates for the point. So let me put a piece of graph paper out there. So there's our graph, and the particular point number 2 is -2, 7 pi over 4. So let's draw this is the radius and this is the angle. So if we draw a circle of radius 2, like that, and so 7 pi over 4, this is going to be 8 pi over 4 is 2 pi. So this is going to be 7 pi over 4 would be this angle. But because this is a negative number, this thing goes the opposite direction. And so that is going to be the end point right there. So that would be the coordinate. So again, this circle represents a radius of 2. So everything's distance of 2. We go around to 7 pi over 4, which is this distance, pi over 4 less than 2 pi. And then the radius is negative, so it goes opposite of where we would expect. Okay, so that's the graphic way of doing it. And so we have the conversion from polar is x is equal to r cosine theta, and y is equal to r sine theta. So if we do x, r is -2, the cosine of 7 pi over 4. So I have to make sure that our calculator is in radians, which mine is now. So we take -2 times the cosine of 7 times pi divided by 4, 7 pi over 4. So our x value is -1.414. And our corresponding y value would be equal to -2 times the sine of 7 pi over 4. So if we put that in our calculator, we have -2 times the sine of 7 times pi divided by 4, close the parentheses, and we get 1.414. And that's the coordinates of this particular point, -1.414 and plus 1.414. So if I were to write the x and y coordinates, it would be -1.414, comma 1.414. This is negative, this is positive, which puts us in the second quadrant.
Recording started.
Okay, problem number 13 asks us to find 2 sets of polar coordinates. The 2 sets are going to be one where the radius is a positive number and one where the radius is a negative number. And our 2 conversions are that r squared is x squared plus y squared, and that the tangent of theta is equal to y over x. So we can find r squared is just going to be equal to -3 squared plus 4 squared, which is 9 plus 16, which is 25. And therefore r is equal to plus or minus 5. So that's going to be our 2 r coordinates. And then we have to use the inverse tangent here to find theta. So what we need to do is figure out what quadrant we're in by just sketching this. So if we go x is -3, y is +4, that puts us in quadrant 2. So we know the answer has to be between pi over 2 and pi. That's for positive r. and then we can have a negative r. We go all the way around and then take a negative r. Okay, so that's going to be in quadrant 4. The second one, the negative r, will be have a quadrant 4 angle. And remember, this is the reference angle, this here, which is, so what we're going to do is we're going to find the reference angle. And it's just the arc tangent, inverse tangent of the positive values here. This will put us in the first quadrant. So if we take the inverse tangent of 4 divided by 3, that gives us 0.927 radians. And if you remember back from pre-calculus, what we would do is we would convert that to some percentage of pi, 0.927. So you divide by pi and you multiply by pi, which is like multiplying by 1. So we get 0.927 divided by pi. So we get 0.295 pi. So that's our reference angle, which has, the reference angle has the same value relative to the x-axis as all the other cases. So theta reference is 0.295 pi, which is between 0 and pi over 2, half of pi, 0.5 pi. So we know it's somewhere in that first quadrant. So the second quadrant solution is going to be equal to pi minus the reference angle. So theta in quadrant 2, or quadrant 2 theta, is going to be pi minus the reference angle. Again, these reference angles, they all have the same angle between the x-axis and the angle. So this angle is pi. If you subtract theta from it, if you subtract theta reference from it, you get the actual angle we're looking for. So we take pi minus 0.295 pi. Well, this is 1 pi minus 0.297, so 1 minus 0.295, sorry. You get 0.705. 0.705 pi. So our first r theta combination is going to be, well, the radius is going to be plus 5, which is going from the origin outwards in the same direction as the angle. And the angle is going to be 0.705 pi. That's the first one. Now, if it's negative, what we'll do is we'd add pi. There's a couple of ways of doing it. We could add pi to this, or we could take the corresponding angle. Actually, we don't add pi to it. Well, yeah, we do add pi to it. So this angle is going to be this plus pi. So let's call this theta quadrant 4. It has to be 180 degrees or pi difference, or it doesn't reflect correctly. Okay, so theta in quadrant 4, that should be theta. Theta in quadrant 4 is going to be equal to theta in quadrant 2 plus pi. So we get 0.705 pi plus 1 pi is equal to 1.705 pi. So our second r theta combination is going to be equal to negative 5 as the radius, because we'll come all the way around here, and then we'll go negative in the negative direction. And we get 1.705 pi. Okay, let me just pause this for a second. I need to get my solution.
Recording started.
Okay, so I've checked the answer, and you probably realize, you see there's a difference, but the only difference is that they've multiplied out. So if you take 0.705 times pi, you get 2.21 radians. And likewise here you get negative 5. If you take 1.705 times pi, you get 5.36. 5.356, 3.356. So those are the answers that are in your book. So again, what we do is we use these two conversions. We find that the radius can either be plus or minus 5. Based on the original coordinates, that place is in the second quadrant. So we know with the positive r that we're going to have this angle, which let me just show by the green here. So the way we find this angle is we calculate the reference angle, which is in the first quadrant, by taking positive 4 divided by positive 3. Just take the positive x, y, and x values. We find that it's 0.927 radians, or 0.295 pi radians. If you take this times 3.14159, you get 0.927. So that's the reference angle. To find the original theta that we're talking about in quadrant 2, you take pi, which is all the way around, you subtract the reference angle, and that remains, what is remaining is the green. So that's what this green angle is. It's right here. So let me just underline that with green. So we have a theta and we have a radius, positive 5, this angle. To get the corresponding one in the opposite direction, it's 180 degrees away from this original angle. So it's not 2 pi minus theta reference. It's try to figure out if that's actually is the same thing. Well, actually, I think it is. Well, let's just figure that. Let's just check it anyway. It is 2 pi minus that. It doesn't look like it, does it? If you took 2 pi and you subtracted the reference angle, which was here we go, 0.295 pi. So if we just use the reference angle, say you have 2 minus 0.295, 1.705. Oh, so it is, okay. So, yeah, we still get the same thing. So you can either add pi to this angle. So you take the green angle and you add pi to it, which is what I did here, 1.705 pi. Or you could have taken 2 pi, because these actually are completely opposite each other. This angle and that angle create a straight line. Anyway, so the second point is you go around 1.705 pi, which is to here, and then you go negative. Instead of going positive radius, you go negative radius, which gets you in the same location.
Recording chart.
Okay, we're going to do 23, 24, 25, and 26 in one video. And we're going to do it both analytically and graphically. So let's do it first analytically. So we need to convert this to kind of an XY plot. And because we're used to thinking of things. So 23 is 2 times the sine of theta. So what do we do here? Well, we have that x is equal to r cosine theta and y is equal to r sine theta. So it looks like if we multiply both sides by r, we would get r squared is equal to 2r sine theta. And we also know that from this you can get that x squared plus y squared is equal to r squared. So at this point, once we multiply both sides by r, we get x squared plus y squared is equal to 2r sine theta, which is y. And then if we write this as x squared plus y squared minus 2y, and we complete the square. So this is going to equal 0 because I moved everything to the right-hand side. And if we take half of -2, which would be -1, we square it, we add 1, so we add 1 to both sides. And we get x squared plus the quantity y minus 1, quantity squared, is equal to 1. So this is an equation for a circle, and its center has radius 1, and its center is at x equals 0, y equals 1. So let's look at the pictures, and it looks like C has that property. It's a circle, radius 1. Okay, so that's 23. 24. You've got R is equal to 4 cosine of 2 theta. So what do we do here? Well, we can do the same thing. We multiply by R. So you get 4R times the cosine of 2 theta. Well, one way of doing it is you can use a double angle formula. If you go to the front of your book, you see that the cosine of 2 theta is equal to, which one do I want to choose? Probably, I don't know which one I want to choose. There's 3 different choices here for cosine of 2u. Well, let's just pick one of them. So, the cosine of 2 theta, we've got 4r times cosine of 2 theta, which is, I'm going to use 2 cosine squared of theta minus 1 is equal to r squared. Okay, now what do we do? Well, okay, so this one's not coming to me immediately. Well, let's see. The things we know are that x equals r cosine theta, y equals r sine theta. We also know that x squared plus y squared is equal to r squared. So let's go ahead and replace r squared with x squared plus y squared. So if we have r here, we'd have 4 times the square root of x squared plus y squared. And I'm just thinking, actually, this, what I'm thinking here is that this may not be easy because it's going to be either A or B, and we could probably solve the whole thing by process of elimination, but by what's left over. But part of the thing is this cosine of 2 theta thing, is that typically if you have a rose shape, if you go back to, if you look on page 735, you'll see that if we've got r, some constant times cosine of n theta, it says when n is even, it's going to have an even number of lobes. And so it's going to look like a flower. So just by process of elimination, I'm going to say it's B. And I'm just going to look at the answer book to see if they have any other. Okay, they don't really say. They just make the assumption. So I'm going to use that as an approach for that one. Okay, 25 is R is equal to 3 times 1 plus cosine of theta. And we'll also do 26. So we get R is equal to 2 secant theta. So if we multiply by R, we get R squared, 2R divided by we'll multiply by the secant of theta, which is 1 over the cosine of theta. Okay, it seems like if actually we don't have to go that far. Let's just write it here. If we say R is equal to 2 divided by the cosine of theta, then r cosine of theta is equal to 2, but r cosine theta is equal to x. So we get x is equal to 2, which is a vertical line. So we know that that has to be D. And so by process of elimination, we know that this is A. But also, if you go again to page 735 and you look at the limacons, or however you pronounce that, you see that you've got r is equal to A plus or minus B cosine theta. If we multiply this out, you get 3 plus 3 cosine theta. And so it fits this one. If you look at the right-hand side, you get r is equal to A plus or minus B cosine theta. Because it's just theta by itself, it's not 2 theta like the previous one. So this is a limacon, and it looks like examples on page 735. So that's how that one works. I wonder how they do 26 if they actually... Okay, then we can plot those graphically. Let's go ahead and do it. So let me bear with me while I get the graphing program started. And I'm going to use the newer graphing program. So let me stop sharing that, start sharing the graphing program. And we want two-dimensional plot, and we're going to use a polar version. So f of t is r, so it says r is equal to 2 times the sine of t, which is theta, and we go from 0 to 2 pi, which is 6.29 approximately. So that's the first one, and you see we get a circle, radius 1. So that's problem number 23. Put 24 in, we get 4 cosine of 2t. And we get that, which is B. The third is 3 times 1 plus cosine of theta. And that is A. And then the final one is 2 times the secant of theta. And we get a vertical line. Okay, so that's those problems. This is problem 31 in section 10.4. So, convert the rectangular equation to polar form and sketch its graph. So we get 3x minus y plus 2 equals 0. So we have the conversion that x is equal to r cosine theta and y is equal to r sine theta. Well, we know what this is. It's a straight line. So it'll be easy to recognize when we plot it in polar coordinates. So we put in 3r cosine theta minus, so y is r cosine theta is equal to sine theta. So r sine theta plus 2 is equal to 0. We factor out an r. R is equal to 3 cosine theta minus sine theta is equal to negative 2. And so the polar form of this equation, which is more complicated, is negative 2 over 3 cosine of theta minus the sine of theta. And so let's plot that. So let's close out the last problem. Create a new graph. So in polar coordinates, we said it was negative 3 or negative 2 divided by, let me go find it again here, 3 cosine theta, 3 cosine of t minus the sine of t. And we're going to go again from 0 to 2 pi. We always do that, 6.29. And there you see it. It's a straight line. If I zoom out, does it? Yeah, it has a whole line. Okay, so that's good. So while we're on this, I'm going to do one more example from this particular section. I think yeah. So let me pick another one. So let me go back and get the, so let's pick 33. I can't remember what we did in class, but so 33 is y squared is equal to 9x squared, which is a parabola that looks like this. It was the other way. If it was y is equal to 9x squared, it would be at this direction, but because it's that, and when x equals 0, y equals 0, so just for the origin, what this does is it just affects how quickly, how flat or how sharp that particular curve is. So again, if we have x is equal to r cosine theta and y is equal to r sine theta, we plug that in and we would get r squared sine squared theta is equal to 9 times r cosine theta. So what do we end up with here? How do we solve for r explicitly? Well, it looks like we could have completing the square and then solve for it. So let's just try that. R squared sine squared theta minus 9r cosine theta. So r is the variable, so you've got 9 cosine theta. So you take half of that, so you'd have minus 9 halves cosine theta. So that's half of that, and then you square it. So you would get 81/4 cosine squared theta. Except I can't do that. I've got to factor something out here. I need to get r by itself. So normally you'd factor that out. So you'd have sine squared theta is equal to r squared minus 9r cosine of theta divided by sine squared of theta equals 0. So I can put 0 there. So what is cosine of theta over sine squared theta? Well, I guess you could make it into, well, we'll just leave it as that right now. See what happens. Okay, so we have sine squared theta. It's probably an easier way of doing this, but it's just not coming to me right now. So you would take half of this, except the r part. So you'd have 9 halves, negative 9 halves, cosine of theta divided by the sine of theta, sine squared of theta. I'm just trying to think if I'm missing something here. Okay, and then we'd square that. So what we would have is 81/4 cosine squared theta divided by the sine to 4th of theta. And we add that to both sides. So we get sine, and we'd also have to multiply it by the sine. So let's not get too far ahead of ourselves here. Okay. So we take negative 9r cosine theta over sine squared theta. And we have plus 81/4 cosine squared theta over sine to the 4th theta. And that's equal to 0, but what we have to do is we have to multiply this, and then we're going to add it to both sides. So you have sine squared, and you cancel that out with 1 sine squared, so you'd end up with 81/4 cosine squared theta divided by sine squared theta. And then if you do completing the square, you would get sine squared theta, and then we have r minus 3 cosine of theta divided by the sine squared of theta, and that thing squared. And that would be equal to 81/4 cosine squared theta divided by sine squared theta. So we divide both sides by sine squared of theta. We get r minus 3 cosine of theta over sine squared of theta squared is equal to 81/4 cosine squared of theta over sine to the 4th of theta. And you take the square root, and you would get, and then you would add that, so you get r plus r times cosine theta over sine squared theta plus or minus the square root of 81/4 cosine squared theta divided by sine to the 4th of theta. And you can take the square root of each term, so you get plus or minus, you get 9/4 cosine of theta over sine squared of theta. So you've got two solutions, but this is the same term, so you end up with 3 plus that would be 9, let's see, 12/4 plus, that would be 21/4 cosine theta over sine theta, sine squared theta. That's one solution. If you subtracted it, you have 12 minus 9, which would be 3, which would be 3/4 cosine of theta over sine squared of theta. Okay, so I'm going to stop for a second, and I'm just going to check, see what the answer is, see if I just missed something here, made it a lot longer than it needs to be.
Recording started.
Okay, so now I feel a little silly, but I made this a lot longer than it needed to be. At this point, we could have divided by r, so let me just do it in red. So if you divide both sides by r, you get r sine squared theta is equal to 9 cosine theta, and you divide both sides by the sine. So let me add a page in here. So if you solve for r, you get r is equal to 9 cosine of theta divided by the sine squared of theta, which is pretty close to what I got, but that would have been a lot easier. And then you could write this as 9 if you multiply both the numerator and the denominator by cosine. You get cosine squared theta in the numerator divided by the sine squared of theta, and then you would divide by the cosine of theta. And so you'd have 9 cotangent squared of theta times cosecant of theta. Is it cosecant? Okay. That would be one way of doing it. There's one additional way of doing it here. If you, let's see, what are we doing here? This would be the same as 9. You'd have 1 over sine squared, which would be cosecant squared of theta, and then you have the cosine in the numerator. So you'd have cosecant squared of theta times cosine of theta. So that would be the equation that is equivalent.
Recording started.
This is problem 38. So what we're doing is we're converting the polar equation to rectangular form and sketching its graph. So 38 is R is equal to 5 cosine theta. So when you have these, a lot of times the best thing to do is if you multiply by R, both sides by R, so you get 5 equals 5, R squared is 5R cosine theta. A lot of times you have this R cosine theta or R sine theta. And you can use the substitutions for x squared. For r squared, you can put x squared plus y squared, and then this becomes 5 times r cosine theta is x. So we did one like this earlier. It came out to be a circle. So you can do the same thing here. You can subtract 5x on both sides so that the right-hand side becomes 0. And then you can complete the square. You take 1/2 of -5. You get -5 halves, and you square it, and you get 25 fourths. So you add that again on the right-hand side. There's no additional term because you don't have a coefficient in front of it. So this becomes x minus 5 halves squared is equal to 25 fourths. And I forgot the y squared. Hold on. So this is going to be a circle with a center at x equals 5 halves, y equals 0, and the radius is going to be equal to the square root of that, which is going to be 5 halves. So we should end up having this go, one side of this circle should go through the origin. So let's do that. Let's look at it. So let me start sharing the graph program. Let's close that. Open up a two-dimensional equation. If we plot it in polar coordinates, we get R. We get 5 cosine theta, cosine of t in their lingo. We go from 0 to 2 pi, which is 6.29. We say OK, and we're expecting a circle that is offset to the right-hand side of the origin. And there it is. So the center is at 5 halves, which is 2.5, has a radius of 2.5, so the one part of the circle just touches the x, the origin.
Recording started.
So before we finish the problem, let's just look at a couple of other examples. 39 was r is equal to theta. And if you do this, you plot it and you get a spiral. So as theta increases, it just keeps going around like that. 40 is theta is equal to 5 pi over 6. Anytime you have a polar equation with a fixed angle, basically what you have is you have a straight line. So lines, and they're at what angle, and they go to the origin in this case. So 5 pi over 6 is going to be just slightly less than pi. So you end up with this angle. So this angle is 5 pi over 6. So this is positive radius and this is negative radius, so it goes along like that. We've seen this before. R is equal to 3 secant theta. So in this case, the secant is a vertical line. So this is a vertical line at x equals 3. And we can figure that out because if we take r is equal to, let's see, 3 divided by the cosine of theta, which is a secant, you multiply both sides, you get r cosine of theta is equal to 3, and r cosine theta is equal to x, so you get x equals 3. If you had something like r is equal to 3 tangent or cosecant of theta, so you'd have cosecant of theta, that's the same as r3 divided by the sine of theta, so you get r sine of theta is equal to 3, and r sine of theta is y, so this becomes a horizontal line. So that's problem number 40. 2 is one with the cosecant. 41 is with the secant. 37 and 38 are r is equal to sine theta and r is equal to 5 cosine theta. Those end up being circles. R is equal to sine theta, I think, is a circle that is along the y-axis. It has a radius of 1, I think. And then 35 and 36 are r equals 3 and r equals negative 2, and those are just circles. So it's just a line that's all the points that are at a radius of 3. And 36 has a negative sign, but it just makes everything opposite where it is, so you still get the same plot. It's just that you start the plot at a different point. I guess maybe that's okay.
Recording started.
This is problem number 44. Use a graphic utility to graph the polar equation. Find an interval for theta over which the graph is traced only once. So let's write that down. 44. R is equal to 5, 1 minus 2 sine of theta. So, it's going to be it's either going to be, 0 to 2 pi, or it might be 0 to pi or something like that. And so what you could do is you could start out graphing it from 0 to 2 pi, see if you get a full revolution, and then try from 0 to pi and see what happens. So let's try that and then see if we can explain the results we get. And, I think, as long as this is just theta, I would think it would just take 0 to 2 pi. That's my initial kind of guess. So where's the graphing program? There it is. Okay. So let's X out of there. Go to our two-dimensional plot. Polar. So we have 44, which is 5, 1 minus 2 sine of theta. And let's go from there to 6.29. And let's zoom out so we can see if we have a full revolution or not. Okay, so there it is. So if we wanted to cut it smaller, we could go to 3.14159. 3.14159, that'd be 159. So that would be pi. Let's see if it changes. Okay. So you see we only get part of it. So it looks like it has to be 2 pi to get a full range. And you can see if we went to like 4 pi, which would be 12.58, we'll probably get the same curve. Okay, so we don't see anything change. So the answer for 44 is 2 pi. So while we're on this, let's just look at some of the other equations. It seems like I said, all the others should be similar. So I'm going to try 45, which is 2 plus sine of theta. And I'm going to go from 0 to 2 pi, 6.29. And so there you see it. And I think if I just take half of that, which is 3.14, I only get half of or I get part of it. So I think 43, 44, 45, and 46 are that. Now let's look at 47, which is 2 divided by 1 plus the cosine of t. So that is from 0 to pi. If you go at 6.28, we see that. And if we go to 12.56, which is 4 pi, we don't see any change. So it seems to be a similar kind of thing. Now, if we go to problem number 49, which has a fraction in there, you have 2 cosine of 3t divided by 2. So let's just think about this. What would you think? Well, if it was t, then it would probably be done in 2 pi. And because usually if you have 2 in there, if it's 2t, you typically have, let's go back to these special polar graphs. I think they tell you let's just give it a try and see what happens. Okay, so 3 theta over 2. Okay, so there it is. Got 6 lobes. If I went to 6.28, I lose half of it. So it's more than 2 pi. You have to go at least 4. You have to go at least more than 2 pi. But let's try 3 pi. 3 pi would be 9.42. Is that right? 3.16 times 3. So that's 9.48. 9.48. Okay, not quite enough. So if we go to 12.56, you see that we get a full complement, a very symmetric relationship. So I'm not sure what the exact rule is yet. Well, let's look at the next one, which is, well, it doesn't have to be cosine. It just has to be either sine or cosine. If you change this to 5 halves, let's see what would happen. Okay. So let's zoom in a little bit. See what we have. So let's just try 2 pi, 6.28. So you can see that's not going to work out. 12.56. And let's go to something larger. Let's go like to 20. And you can see we just overdone it again. So it looks like in this case, again, we need to have 2 pi, 4 pi to get the entire situation.
Recording started.
This is problem number 69. We did this in class, but just in case you didn't write it down or you were not there. So this is says use a graphing utility to graph the polar equations and find all points of horizontal tangency. So the actual problem in the book wanted you to just do it using the graphing utility, which we will do, but we're going to head and do it out analytically as well. And so when you're in polar coordinates and you want to find what is the slope of the line, if you go to theorem 10.11 on page 733, you find that dy dx is dy d theta divided by dx d theta. And if you use the product rule and substitution, you find out that dy d theta is f of theta cosine of theta plus f prime of theta sine of theta divided by dx d theta, which is negative f of theta sine of theta plus f prime of theta times cosine of theta. Okay, so for horizontal tangency, we need for the numerator to go to 0. So what we need is f of theta cosine of theta plus f prime of theta sine of theta equals 0. F of theta, what is f of theta? Well, f of theta is r, or r is f of theta. So it's 4 sine of theta cosine squared of theta. So we need to find the derivative. We have the function already. We already know that's just, it's given plus f prime of theta. So we need to find the first derivative of this expression, which involves us taking the first derivative using the product rule. So this we could multiply everything by 4. So we'll factor out the 4, and then multiply it by this derivative. Well, the derivative is going to be, the product rule says you take the first term, which is the sine of theta, and you multiply it by the derivative of the second term. Well, the second term is really just the cosine of theta, the whole thing squared, so it's like u squared. So if you take the derivative of this, you get u to the first power, and then the derivative of u using the chain rule. So this becomes cosine of theta to the first power multiplied by the derivative of the cosine, which is negative the sine of theta. So that's the first part of the product rule. The second part says you take the second term, which is cosine squared of theta, and you multiply by the derivative of the first term, which is the sine of theta, so you get cosine of theta. So that's what f prime of theta is. And let's clean that up a little bit. So that's the first power, not a prime. So we have 4 times negative sine squared of theta, sine of theta times sine of theta, sine squared of theta. It's the sine of theta squared, which is the same as sine squared of theta, times the cosine of theta, plus here you have the cosine cubed of theta. Cosine squared times cosine is cosine cubed. Okay, now, let's add a page, put both pages on the screen. So now we're going to do this part. So f of theta is this. So we get 4 sine of theta cosine squared of theta, and we multiply by the cosine of theta. So that's this first term. The second term is f prime of theta, which is 4 times negative sine squared of theta cosine of theta plus cosine cubed of theta. So that's this term, f prime of theta. The whole thing times the sine of theta. That needs to be equal to 0. So what can we do here? Well, let's multiply this out and consolidate terms. So we have sine of theta, cosine of theta times cosine of theta. So the last two terms just become the cosine cubed of theta. This term becomes negative 4. So we have negative 4 sine squared of theta cosine of theta times sine theta. So we have sine cubed of theta, sine squared times sine is sine cubed, and then we have the cosine of theta. And then we have plus 4, this 4 times that term, which is going to be sine of theta cosine cubed of theta, sine theta cosine cubed of theta equals 0. Well, you see we have sine theta cosine cubed of theta, sine theta cosine cubed of theta. So you add those two together and you get 8 sine theta cosine cubed of theta minus 4 sine cubed of theta cosine of theta. And that equals 0. And we can factor out 3 terms. We can factor out 4. We can factor out a sine of theta. And we can factor out a cosine of theta because we have each one of those. So this leaves 2 cosine squared of theta minus what we have here is sine squared of theta. And that equals 0. If we go to the trig identities, seemed like it was something. Seems like something's different than the other day. What did I do here? Make sure I did this right. So you get f of theta times the cosine of theta. And we get negative 4. This is f prime of theta, which is that term, times sine of theta. My dilemma is I thought we had sine squared, just cosine squared minus sine squared of theta. So I'm going to stop for just a second because some things doesn't quite seem right.
Recording started.
Okay, I figured it out. When I took the derivative here, I should have had 2, because I had cosine theta squared, so you get 2 times the cosine of theta to the first power times the derivative of the cosine, which is negative the sine. So this 2 is here, and the 2 comes down there, and the 2's there, and so instead of having negative 4 here, we have negative 8. So this becomes negative 8, and you can factor out an 8 here. Okay, so both of these you can use trig identities for. We can change 8 sine of theta, cosine of theta, into 4 times 2. 8 is 4 times 2, sine of theta, cosine of theta. And if you go to the beginning of the book, you find out that that is equal to the sine of 2 theta. So we'll get 4 times the sine of 2 theta for this part. And then the second part, cosine squared of theta minus sine squared of theta. That's another trig identity, a double angle formula, which says that is equal to the cosine of 2 theta. So this expression says you have 4 times the sine of 2 theta times the cosine of 2 theta is equal to 0. So if either one of these is 0, then the whole thing is 0. So you get the sine of 2 theta is 0. You take the inverse sine of 0. The inverse sine of 0 is 0. So theta equals 0 is one solution. And then the second case is where the cosine of 2 theta is equal to 0. So you take the inverse cosine of 0, the angle whose cosine is that is going to be equal to, that's going to be the x value, so it's going to be equal to pi over 2, or 3 pi over 2 is 2 theta. So theta is equal to pi over 4, or 3 pi over 4. So those are the values, the angles where we have a horizontal tangent line. And if you would plug those back into the original expression, the original equation, which was r here, so let me just copy that. So I'm going to paste that here. And we have the 2 values of theta, or actually the 3 values of theta. So if you put r, or theta equals 0 in there, you'll get r is equal to 0, because sine of 0 is 0, cosine of 0 is 1, so you get 0 times 1, which is 0. So that's one solution. Theta equals pi over 4. You get 4 times the sine of pi over 4 times the cosine of pi over 4, the whole thing squared. So that becomes 4 times the square root of 2 over 2 times the square root of 2 over 2 quantity squared. So we get, when this thing's squared, those cancel out. And when you take the square root of 2 squared, you get 2. So let's just keep it all together here. So you get the square root of 2 over 2 times 2 divided by 4. So that cancels out with that cancels out with that. And you get the square root of 2, which is 1.414. So we have 1 point is going to be r equals, if you do this r theta, you'll get 1.414 R, that's R, and the theta is pi over 4. And you get the same value. If you plug in 3 pi over 4, you'll get the same result as far as the value of the radius. So if theta equals 3 pi over 4, this is going to be negative the square root of 2 over 2, but you square it, so it comes out the same answer. So you still get R is equal to 1.414. So the second point where we have horizontal tangency is R is 1.414 and theta is equal to 3 pi over 4. So those are the answers. And let's go ahead and plot this. Well, it's 1.